Hello. If you remember a couple of videos back, I solved a second order differential equation which was of the form d. Let me just get this pen right. Which was of the form d squared x by dt squared plus kx k dx by dt plus kx equal to 1. Now, I'm not going to go through another identical or similar equation to that, where you've got plus 1 on the right-hand side. But we are going to look at solving an equation of the form d squared x by dt squared plus k dx by dt plus kx equal to -1. So in order to solve this equation, what substitution are we going to use? Well, let's see if we put x equal to u minus 1 over k. Do you remember, for this equation here, where the right-hand side was plus 1, we used x equals u plus 1 over k. And that worked. So I'm theorizing that we can now use for this equation, we'll call it dagger as usual. I'm theorizing for this equation where the right hand side is now -1, we can use x equals u minus 1 over k. So instead of doing the general case, solving the general case, let's look at an example which I'm going to make it up as I go along. So d squared x by dt squared plus 4 dx by dt plus 4 x equals -1. Right, okay, so what happens if we substitute x equals u minus 1 over 4? Okay, well, we know that the derivative x dot is just equal to u dot because the constant disappears when you differentiate, and x double dot, let's make that a bit plainer to see, is equal to u double dot. Okay, so if we substitute u double dot in for d squared x by dt squared, we get d squared u by dt squared plus 4 du by dt, because dx by dt is just du by dt, plus 4 times u minus 1 over 4, which is equal to -1. Let me just double check. Yes. Okay. Let's just go up slightly. Now, this simplifies to give d squared u by dt squared plus 4 du by dt plus 4u minus 1 equals -1. Adding 1 to both sides gets rid of the minus ones on each of those sides. So we're left with let me see, d squared u by dt squared plus 4 du by dt plus 4u equals 0. Now, I'm not going to go into all the step-by-step notation as to how to solve this equation, which we'll call equation dagger. Suffice to say that the auxiliary quadratic equation is, let me just write it like this, is m squared plus 4m plus 4 equals 0. So basically, you just substitute in u, let me see, u equals a e to the mt. You differentiate that, you get u dot equals a m e to the mt, and you get u double dot is equal to a m squared e to the mt. Right? And then if you substitute each of those in for these quantities here, you get this auxiliary quadratic equation out of it. Now, we'll go straight to using the quadratic formula. This is m is equal to minus b. Well, b is plus 4, so it's minus 4 plus or minus the square root of b squared. Well, that's plus 4 all squared, which is 16, minus 4 times 1 times 4 over 2. Right, so we've got m equals minus 4 plus or minus the square root of 16 minus 16 over 2. Okie doke. And we see actually that we've got m equal to minus 4 plus or minus 0 all divided by 2, which is just minus 4 over 2, which is minus 2. And that is probably a repeated root. So let's just take this and double check something. We've got m squared plus 4m plus 4. So we'll write down m squared plus 4m plus 4 equals 0. Let's try and factorize it, because this might factorize. So we've got m and m there. 2 times 2 gives 4, and 2 times m plus 2 times m, or if you like, m times 2 plus 2 times m gives you 4m. So we have actually got a repeated root. So m plus 2 equals 0, which implies that m equals 2, which is is a repeated root. Now I'm going to try and have to use my memory to write down the solution for this equation, because we've got a repeated root of -2, and as usual I forgot to put the minus sign in there. I have a real problem with minus signs. So for a repeated root, let's just erase that. Then u is equal to a e to the m t, or at least that would be one of the values, m1, but in this case m1 and m2 are the same, so we'll just leave that as it is. And then of course we've got plus b t this time. Whoops, I keep pressing this button on my pen. I just can't get used to it. bt e to the mt. Well, we know that m equals -2. So we have u equals a e to the -2t. There we are. Does that look more like a t? Plus b t e to the -2t. Right, okay, well, we can just simplify this a bit. So u equals, well, we can take e to the -2t out. And inside we've got, inside the brackets, we've got a plus bt. Right, so we're nearly there. Now we know that let me see, x equals u minus a quarter. X equals u, let's write this down. We know that x equals u minus 1/4. So we've got u equals x plus a quarter. If we substitute x plus a quarter in for u here, we get x plus a quarter is equal to, let's just get rid of that line there because it's a little bit low down. All right, equals e to the -2t times a plus bt. Okie doke. So we're nearly there. So a solution to the ODE d squared x by dt squared plus 4 dx by dt plus 4x equal to -1 is and we'll write this in green. X, if we carry the, if we subtract minus a quarter from both sides, we find that x is equal to e to the minus 2t times a plus bt minus 1 over 4. And that is the solution to our original equation, which we call dagger. So I hope that's been reasonably helpful, and that you're getting used to doing these equations now. And until the next video, I'll bid you farewell and see you soon. So bye for now.